Let us now discuss problem-solving techniques and strategies using conversion factors. What is a conversion factor? This is a term that converts a quantity in one unit to a quantity in another unit. So like from kgs to grams, or from centimeters to kilometers. So we use numbers that relate to them to convert one SI unit to another. So whenever you have an original quantity, if you multiply it by a relationship equality that we've talked about of one unit to another, for example, if you would say 1,000 grams is 1 kilogram, something like that, then you're probably going to get your answer in grams here. Usually the unit that is the numerator ends up to be the SI unit of your answer, and you get a desired value here that relates to that unit. An example of conversion factor is 2.205 pounds is equal to 1 gram. And this kind of relationship is called an equality. You can call it a ratio relationship. To use them, they must be written as fractions. Of course, fractions are derived from ratios. So if we are to use this representation here, we can say if 2.205 lab is 1 kg, so we can write it as 2.205 lab divided by 1 kg. This division sign is just saying per. You can say 1 kg per 2.205 labs, or 1 kg is really equal to 2.205 lab. So you can write it in either way, with the labs as the numerator, kg as the denominator, or you can write the same equality with the kg as the numerator and the denominator is gonna be in labs. So depending on where you're going, the way to know which of these you're going to use is where you want to end up. So if you're converting eventually to labs, then this is the ratio you want to use. If eventually you want your answer to be in kg, this is the equality or ratio or fraction that you want to use. Let us now show some example on how to use conversion factors to interconvert between one unit term to another. Now, the goal here is to make sure we are cancelling the SI units that we started with, as we keep where the SI unit that we need. If a unit appears in the numerator in one term and the denominator in the other term, those units must cancel. What does this mean? So suppose I want to convert 10 kgs to grams. This will be expressed like this. I'll take my 10 kg. I know the relationship between grams and kg. I do know that I'm going to grams, right? 1 gram is the same as 10 to the power minus 3 kg. You can even use 1,000 grams is 1 kg. Either or, you get the same answer. Now, going back to this point, if a unit appears in the numerator in one term and the denominator in the other term, the unit cancels. So the units we are going to cancel here is going to be the kg as the numerator and the kg as the denominator. So we are left with the gram, which is why I was telling you, you have to be careful what you want to use as the conversion factor fraction. Do you want to use this, or do you want to have the kg on top? The best version to use is this, because we are going to the gram. So I'm showing you just what this statement means, and the answer here would be, let's see what that answer would be. 10 divided by 0.001. 0.001 is just 10 to the power minus 3, and it's telling me the answer is 10,000 grams. Okay, so you see this unit survived. That's what this statement is saying. The goal is setting up the problem in such a way that we make sure that all unwanted units must cancel out, just the way I canceled my kgs up there. Now let's do another example here shown in the slide. We are asked to convert 130 labs to kgs. So we need our answer in kg, given we are given our unit, starting unit in labs. So we have to use some sort of a conversion factor, which I believe is 2.205 labs is equivalent to 1 kg. Okay, now where are we going? We are going to the kg. I don't want to use this fraction representation. I want the kg on top, which is what I emphasized before. So to do the problem, I'll take my 130 labs, 130 labs multiplied by my conversion factor. That will help me to interconvert from the original unit to the desired unit in kg. And doing so, you see this is appearing as a numerator on top. This is denominator. Those cancel out. We bring our calculator. We say 130 divide by 2.205, and the answer is 58.96 about. So 58.96 kg survived. But you realize that our question here has two significant figures. So we have to report our answer to sig figs. It's written as 130, not 130 dot. These will be three significant figures, but these will count only the 1 and the 3. The 0 is not significant. So we have to report this answer to two significant figures. So this is how far we should go. But I look at this number is 9 is greater than 5. So my 8 in 58 is going to be upgraded or rounded up to 59 kg as our final answer. You'll be seeing your homeworks asking you to report to the correct sig figs. That is exactly what we've done. Like I said, this is the ratio you want to use that relates a kg to a lab. Okay. You want the kg to be on top and not the other way around. Again, the answer was reported to two significant figures. Be very careful about that. Now, let's see some examples on how we can use conversion factors. The first one is using one conversion factor. There are other calculations that require you to use more than one conversion factors. Example number 1 is right here. Example number 1, how many grams of aspirin are in 325 milligrams tablet? So I usually like to write my needed. My needed is some unit in grams. Okay, my given is 325, my unit in milligrams. So we will have to work with that. And in this case, we'll say that our plan will be converting our 325 milligrams to some grams. So that is a plan. We have to go from milligrams to grams. Now you realize that grams are bigger than milligrams, so our numerical answer is going to be very small. What is the relationship between a milligram and a gram? We know from an earlier lecture that 1 milligram is 10. Milli is like 1,000. 10 to the power minus 3 of a gram, because it's smaller. Someone else will say 1,000 milligram is 1 gram. Now, whichever of these that you can relate is fine. But now, since we are going to the gram, we would want our gram to be, let me use this that you had in your table. You want your gram to be the numerator. So 10 to the power minus 3 gram is really 1 milligram. But like I cautioned you, if another person uses this, the answer will still be same, because it's like multiplying the numerator by 1,000, the denominator by 1,000. You get that. Okay, identify the original quantity and the desired quantity. We've done that. This is the given. I call it, and this is the needed. I called it the needed. Then the next step, you just use your relationships. Okay, I see here the slide is using this version of the relationship, but you can as well say 10 to the power minus 3 gram is 1 milligram. You still get the same final answer. So again, 1 gram is 1,000 milligram. And so all that is left is to do the problem. So we'll take our 325, the given milligram, and multiply by our conversion factor. You can use that, or another scientist would say 10 to the power minus 3 grams is 1 milligram. Both of them will yield the same answer. And in this case, it will be 0.325 grams. Like I told you, we expect our unit value to be less than 325 because we are going from a smaller SI unit, milligram, to a bigger one, which also happened to be our base unit. Do we keep the 3 sig figs? Yes, because the question problem gave us 3 significant figures right there. Our unwanted units, again, numerator, denominator must cancel out so that the G will survive. This is an example whenever you would require to use one conversion factor in your calculation. There are times when you need multiple of them, which is a problem that will require you to use 2 or more conversion factors in a process that we call dimension analysis, which is a process of doing math all in one mathematical sentence instead of breaking it down into steps. You'll do a lot of this in this class, especially in stoichiometry and the moles calculation. All right. So the next question here is asking me how many liters are in 1 pint. Now, pint is quite small. You want to, the plan here will want to convert the pint first to quarts, and then from the quarts, we can get ourselves to liters. Now, any arrow in our plan here means we need a conversion factor. What is a conversion factor of pints to quarts? Since we are going to quarts, we're going to say 1 quart is really 2 pints. You don't want to write it you don't want to write the inverse of this, which is this, because you are going to the quarts. You want this version of the relationship. Now, the conversion factor here, the second conversion factor here will relate a quart to a liter, because you're coming from now a quart, which is the unifying factor, and we go to the liter, and that will use this version of the relationship. We know that 1.06 quarts is 1 liter. So since I'm going to the liter, I'm going to make sure that my liter will be the numerator and my quart will be the denominator. Now, knowing that, you can now write a dimension analysis of this problem. How many liters are in 1 pint? So what you do, you take your pint that was given and start multiplying by the conversion factor. 1 quart is 1 pint, and 1 liter is 1.06 quarts, or 1.057 quarts. This is 1.06 is estimated. What I want to show you here is that the units are canceling out so that the L will survive. Your answer will be in liters, and that's how you know that you set up your dimension analysis process of calculation correctly when you cancel out some SI units, and then you're left with the desired SI unit. Now, doing the math, I presume you're going to get such a number, but let me give you the unrounded number first. Okay, according to this calculation, it's going to be 0.5, which is 1 divided by 2, divided by 1.057. And the answers giving me here that is unrounded will be well, let me say less unrounded, 47,303, and then we have 689. Let me stop there. There are so many numbers, as you can see in the calculator. There are so many. Now, if I look at the problem, we were given 1.0 pint in the original highlighted problem, this one. This is really two significant figures because we said any zero after the decimal point must be counted as significant. So those are two significant figures. So my answer must be reported to two significant figures, which is right there. I look at the number, first number after that, which is a 3. I know that 3 is less than 5. So I'll drop all those, and the answer turns out to be 0.47 liters, which is what we found here. And that's how it turns out to be two significant figures. So yeah, we always want to write the answer with the correct significant figures. Now let us do some examples using conversion factors to convert one SI unit to another. And the conversion factors themselves are just equivalents or fractions that help us to convert one SI unit to another. Question number 1. Okay, we are looking at examples. We are on question number 1. Can you bring your calculator close? Bring your calculator. Come on, pause the video. Bring the calculator. So we want to convert centigrams. That already tells you that the value here is less than what you're going to get as the answer. You want to convert centigrams to kilograms. The question is, convert 225 centigrams to kilograms. Now, if I'm going from centigrams to kilograms, I cannot just take that big hop. No, I can't take that big jump. I have to go from my centigrams at least to a unifying base unit factor, which is a gram, and that's going to take me to the kg. That is the strategy and plan for this problem. Now, centi means what? Centi is a factor of 100, and we can write our needed conversion factors that will help us in this problem. So you can say that 1 gram is equivalent to 100 centigrams. Someone else can say, you are going to the gram, which is why I'm putting the gram as a numerator, not the other way around. Someone else can say 10 to the power minus 2 grams is 1 centigram. Whichever one of these two that you'll use in your calculation, you're fine. That's the first conversion factor that's going to go here. The second conversion factor will be the relationship between a gram and kg. So one person, we're going to the kg, so one person can say 1 kg, kilo is 1,000 grams. Or another one can say 1 gram. Okay, 1 gram is 10 to the power minus 3 kgs. Again, whichever of these you can use in your calculation, you're fine. Because if I multiply this by 1,000, guess what? It gives me that. If I multiply this by 1,000, it gives me this. They can be used interchangeably. So we now come here with our plan. In our dimension analysis, I call this method dimension analysis, and you better get used to it as soon as you can, because you'll use a lot of this coming up in other chapters that have heavy calculations. So we have 225, or we are given 225 centigrams. What do we need? We need our answer in kg. We are given 225 centigrams. I'm going to multiply that by my first conversion factor. 1 gram is 100 centigrams. And then I use the other conversion factor for kg. 1 kg is 1,000 grams. If you want to know you did it right, the numerator unit, denominator unit, similar units cancel out. Grams and grams cancel out. Look, we are left with kg. Our answer here will somewhat be something in kg. And let's do the math. So 225 divided by 100. Again, we divide by 1000, and the answer we are getting here is 0.00225 kg. In the question, we have three significant figures. Never use your conversion factors to decide the sig figs. So this is correct. This is three significant figures because any digit including 1 and 9 is significant, but not the zeros. So you can keep it like that, but in scientific notation, this will be 2.25 times 10 to the power negative 3 kg. How do I know that? If I move this decimal in this standard form to the right, so if you have a number value in standard form and you move the decimal point to the right, your power of 10 must be negative the value of how many steps you skipped. So we skipped 1, 2, 3 steps to get here. So this is an example that showed you using multiple conversion factors. We ended up using 2 here. Sometimes you can even use 5. Okay, let us look at the next example. In this example 2, we are asked to convert 1.5 hours to seconds. Now you and I know that our plan cannot just hop from hours to seconds. We have to go through minutes. So we'll have to convert our hours in our plan. We have to move from hours at least to minutes. And then after the minutes, then we can go to seconds. That's the idea. What are our conversion factors? So I know that 60 minutes is equivalent to 1 hour, and I put the minute as the numerator because that's where I'm going. And then I also know that 60 seconds is 1 minute. I put the seconds above the minute and not write it like this. 1 minute is 60 seconds because I'm going to the seconds. So this conversion factor will be used there. This conversion factor will be used here to help us convert minutes to seconds. So now we come and do our problem. So I take my 1.5 hours that's given in the problem, and then I introduce my conversion factors one at a time. This is the method of dimension analysis. I talked about this before. You know you've done it right when the SI units are canceling up and down. We're left with seconds, so our answer here is seriously going to be in seconds. Okay, so we are right. Our setup is correct because the question wants us to report to seconds. I come to my calculator and say 1.5 times 60 times 60. I get 5,400 seconds. So this is telling me that 400 seconds is really equivalent to 1.5 hours. Very doable. The goal here is for you to know what conversion factors that you need, and you try to strategize and make a plan for yourself on how you'll solve the problem. Now, the question has two significant figures, and so I should try and report my answer to two significant figures. 5,400 itself is two significant figures because there's no decimal here. But we don't like leaving it like this because it's ambiguous. Someone else can write it as 54 times 10 to the power 2. Someone can write 5.400 times 10 to the power 3, you know. So to report these to two significant figures, I use scientific notation, which is where we introduce 10 to the power. Assume the decimals here. We are going 1, 2, 3 decimal places. So this will be the scientific notation version of our 5,400 seconds. So I've shown you how to use conversion factors. At least now it's just to apply with all other SI units.